All right, we'll go ahead and get started. Today we're going to talk about regular expressions. Has anyone in here done regular expressions? Ooh, no one. Okay, well then I'm glad I'm discussing regular expressions. These are used a lot. They're mainly used to do simple pattern matching. Does this text match this pattern? Or does this piece of text have certain characteristics in it? Where have you encountered that before?
If else, right? Like conditional statements.
When you're using a website, right?
Oh, okay.
Using a website, when do you have requirements on the text you're putting in?
What you said? Sorry.
When do you have requirements on the text you are putting in?
Like with credit cards.
Credit cards, right? So validate it's a valid credit card. That's a very common thing for regular expressions. What else?
Like a date.
A date. Make sure your date's in the right format. Another common use of regular expressions.
A social security number.
Social security number. Passwords. Yeah, so these are used a lot because they're actually pretty, once you understand some of the syntax with them, they're pretty straightforward. And they solve a certain problem extremely well. And not just Java uses regular expressions. Pretty much by almost, I think, any language I can think of has some type of regular expression library in it. Even C does. All right, okay, wow. It's really a pattern matching tool. The regular expression either matches the text, part of the text, or fails to match at all. So you have three conditions in Java. It either matches the whole text, matches only part of it, or fails to match any of it. Now this is actually a little different. Most regular expressions either match the whole thing or don't match at all. But Java allows this third condition where there's a part of it that it matches. Let's see. They're extremely useful for manipulating text. Y'all probably, a lot of times thinking about parsing or reading in text, are somewhat annoyed, I guess. Like, oh, why do I have to do this? Regular expressions will actually help you with this a lot. Okay, generation web page, great. Wow, we're just gonna keep doing the long thing. All right, Perl. I don't know why I went into Perl here. By the way, I stole these slides from someone else. Fair warning, FYI. These are not mine. But Perl uses a lot of regex. Perl used to be an extremely popular web programming language. Not so much anymore. It's been replaced by JavaScript and somewhat of Python and PHP. But those, again, use regular expressions all over the place. Okay, so first example, here's a first regular expression. You have two brackets, A through Z, and a plus. Basically, it matches a sequence of one or more lowercase letters. The brackets A through Z mean any character from A through Z inclusively, so a lowercase letter. The plus means one or more. So when you combine those two together, one or more lowercase letters. So let's suppose we apply this pattern to the string now is the time. Does that regular expression fully match the string? And I said that backwards. Does the string fully match the regular expression, or vice versa? I guess either will suffice.
No.
No, why?
Yeah. Oh,
Capital letter.
Capital letter. What else? There's one other thing.
The quotation.
The spaces. I will say inside the quotes. Good thinking, but let's go inside the quotes. Yeah, so two things. You have uppercase and spaces. We can try and now we can apply this three different ways to the entire string, which it does fail because the string contains things other than lowercase letters, namely an uppercase and a space. To the beginning of the string, which it also fails because it starts with an uppercase letter. We can search the string, which will succeed and match OW. Why would it match OW first?
First lowercase letter.
It's the first part of the string, the first part of the string that matches, the regular expression. But doesn't O match that as well? Wouldn't just the letter O match the regular expression?
Yeah, but you
The
have
whole
a
word.
plus sign, so you go plus one more, but then there's a space, so it ends it, right?
The whole string.
So with regular expression, I didn't tell you this. but they try and match the longest thing possible. They always search, they always keep going, trying to find the longest match before it returns something. So yes, it's going to do OW. That's also why it'll be it. What would be next? What would be the next one after OW?
Would be time. Or no?
No.
Even though
Is.
that's the longest?
Is. No, no.
Right next to it.
Oh, okay.
Is. Now what's going to come next? The, or V, and then
Time.
time. So it would match 4 different things in that string. And then after the 4th time it would fail because there's nothing left. All right, let's go do it in Java. Let's create a new Java class. We'll call it regex examples. Regex, that's a lot of EXs in there. Add that to Git, close that window, right click, close the others. Public static void main string args. And this one's probably going to do a pattern and then a match. Yeah, it's going to do pattern. So first thing we do is ooh, that's not pattern. Pattern p equals new pattern A through Z plus.
Let me just say, that'd be a good rap name.
Pattern pattern p. Thank you, Tyler. I feel better now. Has private access. Did I miss something? .compile, that's right. So it's a little different. Oh, why is that red? That should not be red. .pattern with the string. Did I miss something? Good morning.
Come on.
We run it and get the full error here because I don't see what it is.
I thought it was the start of pattern.
Class compile pattern dot. Oh, that's right. We have the word new there. Okay. Whew. That was weird. That was close. Whew. All right. So this is syntax is a little different than what you're used to. It's doing. Actually, let's see. Who can tell me what exactly is happening on this line? I got it.
Compiling the pattern.
It's compiling a pattern. All right, that is what it's doing semantically. But what is it doing syntactically?
Creating a pattern.
Okay.
On a pointer to the pattern.
Right, point to the pattern, so that's that pointer P, it's called P. So P is going to point to a class pattern. Then what is it doing?
And then it's creating an object pattern?
It is creating an object. How is it creating that object though? Yeah, here, it's a little tricky. So it's calling a function compile, which is part of a class pattern. So it has to be static. So it's calling a static function of pattern, which is going to construct a pattern object based on the string you passed in. So it's a little different than what you're used to. You're probably used to new, but in this case it's called the factory method because .compile is factory, aka it produces patterns, and it's going to create a pattern for you and return it. All right. Then we probably want to do matches next, I would assume. Yep. So next comes the matcher, m equals pattern dot, oh, I'm sorry, p dot, what is it, pattern? No, it's matcher. What was the string? Now is the time? Yeah. Now is the time. All right, let's go ahead and import matcher. Okay. So the matcher, again, this is another factory method because you're calling p.matcher, which is going to produce a matcher object that is going to be built from now is the time string applying the pattern that you put above it. There. Let's see what capabilities we have inside of matcher. M dot. Oh, we got lots of stuff. Matches. So that's going to tell me if the string flat out matches. Which does it? Does the string match the regex? No, not at all. So it should produce false. Perfect. And then I think next came the right, looking at returns true if the pattern matches at the beginning. And then find, all right. Call to mfind will return true. Hold on, there should be a, you've got to be kidding me. There we are. Oh, that's a little weird. Okay. So while m.find, aka while it's inside the pattern, it can find something. You want to basically get, what do we have? I'll say system dot, we'll do.
Do you not need to put P in the parentheses of m dot matches? So what is it comparing him to?
Okay, hold on. Ask that question again. I think I got sidetracked to what you were trying to ask.
I thought you would need to put P in the parentheses of m dot matches.
No. Notice, that's a good question. Notice here we're creating a pattern calling P. Then we're using P to create a matcher based on the string. So it already has a handle essentially back to P, back to the pattern.
Okay.
So now you just have this one object that you can find out if it matches, because the matches object contains both the pattern regex and the string you're trying to match it against. So it's already taken care of that for you. So that's string S, what do we have? Oh, how did they do this nicely? Did they? Oh, okay, sure, we'll do that. String text equals now is the time. And we'll go and pass that text in. And then here you do text.substring m.begin. Isn't there a begin? Start. m.end. Next string plus s, and then we'll end the quotes dot. Alright, so now if we run it, it should go through each one. Now is the time. Okay? If I were to make that first letter a lowercase n, what would it do?
NOW.
For the first one? Right, so the first one should be NOW. Or it won't do anything. How did we get that wrong? Oh, does it skip the first thing? Looks like it skips the first one. So let's go ahead and put a space in there. Now is the time. All right, let's go back to what it was originally. I'm going to wrap this up in a separate function called simple. All right. Any questions on this example? Most of the time you just care about matcher, in which case the function you really want to write is basically public static boolean matches string regex string text, and all this would probably do is pattern p equals pattern.compile of the regex, and then we would just return p.matcher of the text.matches. And so that's basically going to say, does the regex you just passed in match what comes in? So I can do system.out.println matches stack match. Let's go with matches. So here we'll do the A through Z plus, and then hello, hello, and should that match?
Yeah.
Yeah, and should the second one match? No. All right. There we go. How's it going? Following so far? All right. let's see. There are some additional methods that you may find helpful in the future. You won't need them for this lab. But you can, what do we have? Replace first, returns a new string where the first substring matches the pattern, replaced by replacement. All right, so you can actually start replacing things that match a pattern, replace everything, find the start index, and then reset the matcher. So there's different tools to basically investigate a string and maybe replace what you find. Okay, so some simple patterns. ABC has to be exactly this sequence of 3 letters. In other words, if we were to go over here, copy, paste, and I were to type in ABC, that means the next string has to be ABC for it to pass. If any of it was not matching, like it was just AB, it'll be false. So if you just type in character straight, you're saying I explicitly need to have this character right here. Oops, next one. So when you use the brackets, it's any one of the characters. So that's why if we go back and we do A, B, C, and then we just have A, it'll match because A is one of the 3 characters, as well as I used B. It would be one of the 3 characters. Now note, if I did BB, it's not going to pass because it's just saying only one of those characters, not more than one.
So is that kind of same like the Linux commands when you're trying to find like a document, you do like the brackets and you like put in?
Yes. Yeah, they are using regex as well. You will find this everywhere. Now the syntax will be a little different based on which system you're using, but the idea behind it is the same. The not means any character except the ABC. So this is literally the reverse. So normally AB would match, but if you do not ABC, it's going to return false the next time. There we go. Because it can't be A, B, or C. So we could just have a space, and we're good to go. But if we have 2 spaces, it's going to fail because we're saying it has to be just one character that is not ABC.
So you could put the plus on the end of it to make it more than one character?
Then it would be any group of it would be one or more characters that are not ABC. So basically, I could then type what as long as I don't use an A, I want, and it should still pass. See, true, but the second I put an A in there, false. Good so far? Doing great? All right. So any one character A through Z, that dash is a nice little shorthand. We talked about that a little, or I've already showed that. And you can combine these. So lowercase A through Z, uppercase A through Z, and 0 through 9. Go ahead and put that back on the next line. So let's go. A through Z, capital A through Z, and 0 through 9. So will that match?
Yeah.
Yeah, that should actually match. Now, let's just say I turn this into a 9, and that'll still match. Notice that true down here. But if I changed this to 0 through 8, it's going to fail because it's only going, because, yeah, 9 is not included. Just try to give you more and more examples here.
So how would you do symbols? Like you got a period or exclamation point?
Right, let's get to that in a minute. Morning. Yeah, if one pattern is followed by another, they must match consecutively. So for example, capital A through Z, capital A through Z, any number of those followed immediately by one digit. So, what do we have? We'll put a plus right here, and then a single 0 through 9. So that means, do I match 3. That should match because it ends with a digit. 0 through 9. But what would I need to do in order to match that one?
Another digit.
Yeah, just one more digit. Now notice that is forcing it to have 2 digits right next to each other. So it has to have 2 digits inside of it. C, vertical bars separate alternatives. Yeah, so you can do either A, B, C, or Y. Okay. So that can sometimes get a little confusing. Let's take this to the next level. Cool. All right. Let me see if I typed that in correctly. Sometimes I don't. Good. So what is this one saying?
You can either have any letter from A through Z, like 1 or more, and then or you could have any digit from 0 through 9, 1 or more.
1 or more. All right. So A, B, C. Does that match?
Yes.
All right. Oops. That's not what I meant to type. A, B, C matches. How about 1, 2, 3?
Yes.
All right. How about ABC 1, 2, 3? No. Why does that not match?
This is either or.
Yeah, it's either or. It's not inclusive. You can't have both. It's one or the other. All right. Okay, we'll have that just bump out there right now. Here we go. All right, so there are some shorthands to help you out. So you don't have to do 0 through 9 all the time. You can just do \D. You don't have to do non-digit, that's \big D. You don't have to do white space. By the way, there's a lot of weird ones. So \S, and of course not white space. And then a word character is just W. Notice that you also get the underscore. Probably pretty helpful because if you remember, that's how babies are made. Wow, really? No.
The word baby.
The word baby? Those are the characters your identifiers in your programming languages can have, sorry. They can't start with a digit though. So, well, we have A through Z. We could have done, well, we couldn't do A through Z. We'll do \W. Ooh, we didn't like that. There we go, \W or \D. I didn't like that. Why not? Oh, it's illegal escape character. You got to do 2 whacks. So it wants a single backslash when it does it, but if you recall, a backslash is an escape character inside of Java, so to put a single backslash or a whack, as I like to say it, you have to do double whack. Double whack. So that's true. In actuality, \W is probably a terrible example to use here. So we're not going to, let's get rid of that.
Where's that?
We're just not going to do it. Basically what I'm saying is, oops, same as below. They're just some shorthands to help you out. All right. Boundary matching. I'm not going to test you over this, but you can specify, okay, it's got to be at the beginning of the line, okay, it's got to be at the end of the line, maybe a word boundary, and well, you get a lot of different things. Really, the only two that most people use are the beginning of the line and end of the line. Okay, so here we go with the quantifiers. All right, these are very useful. The question mark means you either have one or none. So let's take this one real quick. And make that a question mark. And then we're going to get rid of this or. So, what does that say?
So you need to have one or more characters of A through Z, and you need to have one digit from 0 to 9.
Do you have to have that one digit?
No.
No. You either have one or none.
Oh.
So that's true. That's also why ABC1 should also pass, but ABC12 should fail. All right. All right. The star occurs 0 or more times. So this is like the plus, except for you can have none. So we'll run with this example a little more. So is that going to pass? Whoops, no, that's not going to pass. But will that pass? And then the next question is, does that pass? And then, of course, the last question is, does that pass?
Yes. No, yes.
You have yes, no, yes. I think I have 3 yeses. Yep, they all pass. Because you have 0 or more characters followed by an optional digit. 0 or more characters, no characters, followed by an optional digit. No characters followed by an optional no digit. So it matches the empty string as well. We just did a lot of work for nothing. But that's okay. Just wanted to show you. That's what the star meant. You can have any number of those or none at all. All right, you can do curly brackets where it has to occur exactly a number of times, or you can give it a range. Let me see if I can get this typed out correctly. So we'll say 1 to 4. Oops. So is that going to match? The first one will not. Will the second one?
No. You have 5, right?
So the first one doesn't because you would need at least 1, most 4. Second one does match because you have something between 1 and 4 number, inclusively number of A through Z's. And the last one doesn't match because you have 1 too many characters. Are we doing okay so far? Hopefully these are easy, but they may not be. All right. Reluctant qualifier by appending the I don't know. Oh yeah, basically the question mark is if you ever say, we don't need it, or maybe we do, you can put that there. Wow, okay, that's enough. Suppose your text is aardvark using the pattern A star aardvark. Is that going to match?
Yes.
Yeah, it should match. It does match, but I just want to tell you that even though we'll look at it, go AA and try and replace that with this part, it would say, oh no, it doesn't match. It will back off and have a single A followed by the rest of aardvark. So it does work the way you think it does in your mind. It just may be doing a little extra work. All right, that's fine. We don't care about that. All right, you can actually put things in groups. And this is where it starts to get confusing. Because it's going to start having a lot of levels going on. Let's see, do we get to do it? Nope. All right, let's do it that way. Okay, let's go with an example. Let's see, we have this A through Z running. So we'll put, it's either that or, I don't know, capital A through Z, any number of those. Boom. There. Got it. Okay. What does that say?
Okay, so
Here we go. Look at this from the back. This,
so would you do two different strings? Like, is it comparing two different sets of inputs?
it's
Because
going
you're
to
putting
create a
different-
regular expression from the first string, and then see if that second string matches the first. So my question is, what is that first thing doing? What does it say that your string must have?
It needs to have 1 through 4 digits between A and Z.
Okay.
Or A through Z, capital A through Z, as many times. Then there's the plus. So you could have that as many, like that. I have no idea.
You have no idea. All right, so ignoring that plus for now, does that match? Yes, it does actually match. All right, or that should match. Let me run it real quick. Good. ZBCD, is that going to match?
Yes.
Yes. All right. Here we go. How about ABC? Is that going to match?
Yes.
Yes. Why does that should match?
Oh, because you're having another, like the A through Z, 1 through 4.
Yeah, because what you've done with this plus, by making it after these parentheses, whoops, you've stated you can have any number of these or clauses inside of here. So you can actually ABC, ABCD, lowercase, ABC, lower, 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 AB. You know, you're good to go as long as you only have one digit at the end. All right. Any other questions? All right, we don't need to talk about the capture groups. If we can just get this done today, we're doing amazing. All right, what is this? Suppose you want to move all constants to the beginning of the word. Oh, we don't, no, don't do that. Escaping meta characters. All right.
I almost thought you said escaping Medicare for a second.
So,
It's not that.
what if you want to actually match the star or the backslash or whatnot? Okay, this starts to get a little confusing. So the question is, how do we actually take into account special characters? Okay, spaces, thanks, sporces. Does it not tell you? It doesn't? Oh my goodness. Okay. Wow.
You seem appalled.
I am always appalled.
What are
Hmm?
they? I said, what are they? Not including characters.
All right. If I recall correctly, it was like this. Yeah. So you start it with the double whack and then the star. And then if you actually want to do the double whack itself, okay, you got to do 4 of them. I know. Just roll with it. There we go. All right. And just make sure it's inside the solid brackets. All right. I'm going to wrap this up into what's called many examples. Hmm? Wow, that was a lot of examples. All right, lastly, I'm going to pause the recording and then we're going to do a quick exercise. Well, hopefully it'll be quick.